Good morning, students. So far we have discussed the basics and fundamentals that is required to solve the exercise 5a. Now let us start the exercise 5a of the chapter hyperbola. So the question is, one focus of a hyperbola is located at the point -1, 3. That is, this is the fixed point called focus. And the corresponding directrix is the line y is equals to 2. Y is equals to 2 is the line which is parallel to x-axis. That is a horizontal line. Find the equation of the hyperbola if its eccentricity is 3 by 2. 3 by 2 is 1.5. That means we have already discussed that the eccentricity of a hyperbola is greater than 1. 3 by 2 is obviously greater than 1. So therefore in the question the focus is given. So given that focus S -1, 3, directrix L is y is equals to 2 or y minus 2 is equals to 0 and eccentricity E is equals to 3 by 2. Let Px1, y1 be any point on the locus of hyperbola. By definition of conic, SP by PM is equals to E, where SP is the distance of a point from the fixed point focus and PM is the distance of a point P from the directrix or the perpendicular distance of a point P x1 y1 to the line given. So this is equals to SP is equals to EPM, squaring on both sides, SP square equals to E square PM square. So SP is S is the focus, P is the point x1 y1. So distance between the 2 points, x1 minus 1 whole square plus y1 minus of minus. So y1 plus 3 whole square is equals to E square is 9 by 4 into PM square, the perpendicular distance from the point x1 y1 to this line. So this is in the place of here 0x, 0 in the place of x1, 0x1 is 0. So in the place of y1 minus 2 by square root of the quotient of x plus square of the quotient of y. So here x is absent, so square of the quotient of x is 0 square plus the y quotient is 1, its square. This is equals to 4. If you cross multiply, then this we will get 4 into this x1 minus 1 whole square plus y1 plus 3 whole square is equals to, this is 9 into SP square, square root gets cancelled, E square, PM is the perpendicular distance from a point P to the line, so square, so that means this whole square. So this is y1 minus 2 whole square. PM is the perpendicular distance from a point P x1 y1 to the line. So modulus of ax plus by plus c by ax1 plus by1 plus c by square root of a square plus b square, its square. So now this is 4 into a minus b whole square, x1 square plus 1 minus 2x1 plus y1 square plus 3 square 9 plus 2 3 is 6 y1 is equals to 9 into y1 square plus 2 2 is 4 minus 2 2 is 4. So y1 square minus 4, so 4y1. So this is equals to 4x1 square. This is 4 into y1 square, 4y1 square. This plus 9y1 square, if you bring to this side, minus 9. 4 minus 9 is minus 5 1 square. Next, 4 2s are minus 8x1. 4 2s are minus 8x1. Here 4 4s are 4 6s are 24y1. This 9 4s are minus 36. Minus 36 if you bring to this side, 24 plus 36 is 60y1. So plus 60y1. Next, 9 plus 1 10. 10 4s are 40. 9 4s are 36. So 9 plus 1 10. 10 4s are 40. 9 4s are 36. 40 minus 36 is plus 4 is equals to 0. So therefore the locus of Px1y1 is the locus of Px1y1 is 4x square minus 5y square minus 8x plus 60y plus 4 equals to 0. So this is the required hyperbola, and if you got whether this actually represents the hyperbola or not is based on the concept the second degree non-homogeneous equation. This is the second degree non-homogeneous equation. So the second degree non-homogeneous equation to represents the parabola is h square is equals to ab. Ellipse h square less than ab. Hyperbola h square is greater than ab. So here 2hxy. So xy term is absent. Therefore h is equals to 0. So a is equals to x square quotient. B is equals to y square quotient minus 1. So here h square is equals to 0. AB is equals to minus 20. Clearly we see h square is greater than AB. 0 is greater than a negative term. Therefore, yes, this represents the equation of the hyperbola. If the lines 3x minus 4y equals to 12 and 3x plus 4y equals to 12 meets on a hyperbola, s equals to 0. This is what is there in the textbook. Some extra information is missing in the textbook. So the extra information is supposed to be of conjugate axis is 6. So this is missing in the textbook. Then find the eccentricity of the hyperbola. So this is the question given. So the lines meets the hyperbola. That means this line and this line meets on a hyperbola. That means the point of intersection of these two is lying on the hyperbola. So then we need to find out the eccentricity. So eccentricity is square root of a square plus b square by a square, or a square plus b square by b square. So conjugate axis is given. So that means 2b is equals to 6, b is equals to 3 is given. So with the data given, a we need to find out, and then eccentricity e is equals to square root of a square plus b square by a square. So this is how we have to solve this problem. Now, so given lines are 3x plus 4y is equals to 12. 3x minus 4y is equals to 12. So the point of intersection of the given lines is just add these two. So is adding 1 and 2. So then we'll get 3x plus 3x is 6x plus 4y minus 4y gets cancelled. 12 plus 12 is 24. From this x is equals to 24 by 6, which is 4. Substituting x in 3x plus 4y is equals to 12, any of these two lines, then we'll get 3 into 0 0, so 3 into 4 12 plus 4y is equals to 12, so 12 gets cancelled, so y is equals to 0. Therefore the point of intersection is 4 comma 0. So this meets on a hyperbola, that means this point lies on a hyperbola. So since this point 4 comma 0 lies on the hyperbola which is not given, so s is equals to 0, that means the standard equation of the hyperbola we have to take into consideration. So since this point 4 comma 0 lies on the hyperbola, x square by a square minus y square by b square is equals to 1. This implies x value is 4 square 16 by a square minus y value is 0, so 0 by b square is 0 is equals to 1. From this 16 by a square equals to 1, a square equals to 16, so from this a is equals to 4. So given that if x square by a square minus y square by b square equals to 1 is the standard form of the parabola s is equals to 0, then the conjugate axis is 2b. So 2b is equals to 6. So from this b is equals to 6 by 2, which is 3. Therefore the eccentricity E is equals to square root of a square plus b square by a square. Square root of a square is 4 square 16 plus b square is 9 by a square is 4 square 16. So root 25 by root 16. This is 5 by 4. Find the equation of a hyperbola whose foci are plus or minus 5 comma 0 and the transverse axis is of length 8. So plus or minus 5 comma 0 is given. That means the transverse axis is along x-axis. If 0 comma plus or minus 5 is given, transverse axis is along the y-axis. So this is the question. Given that foci s is equals to plus or minus ae comma 0. This is equals to plus or minus 5 comma 0. That means AE is equals to 5. This is given. And the transverse axis is of length 8. So the length of the transverse axis is 2A is equals to 8. From this A is equals to 4. With this available data A equals to 5, A equals to 4, we need to find out the equations of the hyperbola. So from this a square e square is equals to 5 square 25. Here a square is equals to 16. We know that a square b square is equals to a square into e square minus 1. So when the transverse axis is along x-axis, so b square is equals to a square e square minus a square into 1 a square. So b square is equals to a square e square is 25 minus a square value is 16. Therefore b square is equals to 25 minus 16 is 9. Therefore the equation of the required hyperbola is x square by a square minus y square by b square is equals to 1. From this x square by 16 minus y square by 9 is equals to 1. So if you take an LCM here, 9x square minus 16y square by 16 9s are 144 is equals to 1. So if you cross multiply is equals to 144. This is the equations of the required hyperbola. Find the equation of a hyperbola whose asymptotes are the straight lines. X plus 2y plus 3 equals to 0, 3x plus 4y plus 5 equals to 0, and which passes through the point 1 comma minus 1. So we have discussed about the asymptotes. Asymptotes are nothing but the lines which are passing through the center of the hyperbola and which touch the hyperbola at an infinity, at infinite point. So given equations of the asymptotes are x plus 2y plus 3 equals to 0, 3x plus 4y plus 5 equals to 0. The combined equation of the pair of asymptotes are x plus 2y plus 3 into 3x plus 4y plus 5 equals to 0. So this implies x into 3x, 3x square, x into 4y, 4xy plus x into 5, 5x plus 2y into 3x, 2 3 is 6xy plus 2y into 4y, 2 4s are 8y square plus 2y into 5, 10y plus 3 3s are 9x, 3 4s are 12y, 3 5s are 15 equals to 0. So this implies 3x square plus 6xy plus 4xy, so 10xy plus 8y square plus 5x plus 9x, 14x, 10y plus 12y, 22y plus this is plus 15 is equals to 0. So this is the equation of the asymptotes, and he is asking us to find out the equation of the hyperbola. So we know that the hyperbola and the equation of the asymptotes are defined by a constant. So let the equation of the hyperbola be 3x square plus 10xy plus 8y square plus 14x plus 14x plus 22y plus lambda is equals to 0, because the equation of the asymptotes and the equation of the hyperbola are differed by a constant. The remaining everything is same. So according to the question, according to the sum, the required hyperbola is passing through 1 comma minus 1. So this implies 3 into 1 square 3, 10 into 1 into minus 1 minus 10 plus 8 into minus 1 square 8, 14 into 1 14, 22 into minus 1 minus 22 plus lambda is equals to 0. So from this lambda is equals to, so 3 plus 8 11, 11 minus 10 1, 1 plus 14, 15. 15 minus 22 is minus 7. So if you take to that side, it is plus 7. Therefore, the equation of the required hyperbola is 3x square plus 10xy plus 8y square plus 14x plus 22y plus, in the place of lambda I substitute it as 7 equals to 0. So this is the equation of the required hyperbola. If 3x minus 4y plus k equals to 0 is a tangent to x square minus 4y square equals to 5, which is a parabola, then find the value of k. This is the question and we need to find out the value of k. This is the straight line. So, given equation of line is 3x minus 4y plus k equals to 0. From this, 3x plus k is equals to 4y. Therefore, y is equals to this 4, it will be dividing with this. So 3 by 4x plus k by 4. So if you compare this with the y is equals to mx plus c, m is equals to 3 by 4, c is equals to m is equals to 3 by 4 and c is equals to k by 4. So given equation of hyperbola is this: x square minus 4y square equals to 5. So if you try to write in a proper form, let us divide this with a 5. So x square by 5 minus 4y square by 5 equals to 1. So this is x square by 5 minus y square by, this can be written as 5 by 4 equals to 1. So this is the form: x square by a square minus y square by b square equals to 1, with a square is equals to 5, b square is equals to 5 by 4. Since this line is a tangent to the hyperbola, so line touches the hyperbola. The condition of the tangency is, the condition for the tangency is c square is equals to a square m square minus b square. So the condition that the line y is equals to mx plus c to be a tangent to the hyperbola x square by a square minus y square by b square equals to 1 is c square equals to a square m square minus b square. Remember, this c square is equals to a square m square plus b square for a ellipse. Now, here the value of c is equals to k by 4 whole square. So k square by 4 square is 16 is equals to a square is 5, m square value is, m is equals to 3 by 4 whole square, 9 by 16 minus b square. B square is equals to 5 by 4. So k square by 16 is equals to, so the LCM for 16 and 4 is 16, 5 9s are 45, minus 16 by 4 is 4 times 4 5s are 20. So from this, 16 on both the sides gets cancelled. K square is equals to 45 minus 20 is 25. Therefore, K is equals to plus or minus 5. Find the product of the lengths of the perpendiculars from any point on the hyperbola x square by 16 minus y square by 9 equals to 1 to its asymptotes. So the given equation of the hyperbola is x square by 16 minus y square by 9 equals to 1. So if x square by a square minus y square by b square equals to 1 is the hyperbola, then what is the parametric point? A secant theta, b tan theta. So here a square is equals to 16, a is equals to 4, b square is equals to 9, b is equals to 3. So let P a secant theta, b tan theta. So here a is 4. So 4 secant theta, 3 tan theta, b any point on the hyperbola. So given asymptotes, given pair of asymptotes, let the pair of asymptotes be x square by 16 minus y square by 9 is equals to 0, because the pair of asymptotes and the hyperbola is differed by a constant. So since it is passing through the center of the hyperbola, so this constant I am replacing with the 0. Now the equations of the asymptotes are, so this is the combined equation of the pair of asymptotes. So if you want the individual asymptotes, they are x by 4 plus y by 3 equals to 0 and x by 3 minus y by 3 equals to 0. So let Pm be the length of the perpendicular from P theta to the, this is 1 and these are 2, to the asymptote 1. Then the length of the perpendicular formula is Pm is equals to modulus of a x1 plus by1 plus c by square root of a square plus b square. So in the place of x1, what is x1 here? 4 secant theta. So 4 secant theta by 4 plus, in the place of y1. What is y1? This is x1, this is y1. So 3 tan theta by 3 by square of the quotient of x plus square of the quotient of y. So 1 by 4 whole square, 1 by 16 plus 1 by 3 whole square, 1 by 9. Remember, ax plus by plus c equals to 0 is the line and px1 by1 is the point. So this px1 by1 is the point. So this px1 by1 is the point and this is the line ax plus by plus c equals to 0. So the length of the perpendicular drawn from P to this line is modulus of A. In the place of x, substitute x1 plus b. In the place of y, substitute y1 plus c by a x1 plus b y1 plus c by square of the quotient of x plus square of the quotient of y. So a square plus b square. The same concept I have applied for this. So x1 by 4 plus y1 by 3 by square root of the quotient of x. 1 by 4 whole square plus 1 by 3 whole square, where x1 y1 is the parametric point. Let any point we have taken it to be the parametric point. Now P, so this gets cancelled. So we get Pm is equals to secant theta plus tan theta by 1. This is 9 ones are 9 plus 16. 9 plus 16 by 16 into 9. So this. So 9 plus 16 root 25. This is equals to 25 by 9 into 16 is 144. So this is equals to root 25 by root 144 is 5 by 12. So this, the fraction would be reversed, 12 by 5. So this is what we have got. So Pn is the length of the perpendicular or the perpendicular distance from the point P x1 y1 to the another asymptote. So this we will get secant theta minus tan theta into 12 by 5. So the question is the product of the lengths of the perpendiculars. That means Pm into Pn. This is the product of the length of the perpendicular Pm and Pn. So this is equals to secant theta plus tan theta into secant theta minus tan theta. So secant square theta minus tan square theta into 12 by 5 into 12 by 5. 12 12s are 144 by 5 5s are 25. So secant square theta minus tan square theta is 1. So Pm into Pn is equals to, this is 1 into 144 by 25 is 144 by 25. If the eccentricity of a hyperbola is 5 by 4, then find the eccentricity of its conjugate hyperbola. So let E comma E dash be the eccentricities of hyperbola and conjugate hyperbola. So the hyperbola is x square by a square minus y square by b square is equals to 1. But whereas conjugate hyperbola is x square by a square minus y square by b square is equals to minus 1. So then it is connected by the relation 1 by e square plus 1 by e1 square, or e dash e1 I will take, is equals to 1, where e1 is the eccentricity of the conjugate hyperbola. So this is equals to, given that the eccentricity of the hyperbola E is equals to 5 by 4 is given. So this is equals to 1 by 5 by 4 whole square is 25 by 16 plus 1 by e1 square equals to 1. 1 by 25 by 16 is 16 by 25 plus 1 by e1 square equals to 1. So 1 by e1 square is equals to 1 minus 16 by 25. 25 ones are 25 minus 16 is 9 by 25 is 1 by e1 square. So this is equals to e1 square is equals to 25 by 9. Therefore e1, which is the eccentricity of the conjugate hyperbola, is 5 by 3. Find the equation of the hyperbola whose asymptotes are 3x is equals to plus or minus 5 by and its vertices are plus or minus 5 comma 0. So we need to find out the equation of the hyperbola. So the hyperbola's asymptotes are given. So that means this hyperbola is what we need to find out. The asymptotes are given. These asymptotes are given. So the feature of the asymptotes is they are passing through the origin, which is the center of the hyperbola. So that is why here constant is missing. So the given asymptotes are 3x is equals to plus or minus 5y. So that means 3x plus or minus 5y equals to 0. The equation of the pair of asymptotes or pair of asymptotes means the combined equation, the joint equation. So that is 3x plus 5y into 3x minus 5y equals to 0. So this is 3x square 9x square minus 25y square is equals to 0. So let the equation of the hyperbola be 9x square minus 25y square equals to k, because we know that the equation of the asymptotes and the equation of the hyperbola are differed by a constant. So from this 9x square minus 25y square by k is equals to 1. So this is x square by k by 9 minus y square by k by 25 is equals to 1. So here a square is equals to k by 9, b square is equals to k by 25. So given vertices are, the vertices are a dash plus or minus a comma 0 is equals to plus or minus 5 comma 0. From this a is equals to 5, a square is equals to k by 9, a here is equals to 25 is equals to k by 9. So from this k is equals to 9 into 25 is 144. 9 into 25 is so here k is equals to 25 nines 225. Therefore the equation of the required hyperbola is 9x square minus 25y square is equals to 225. Find the equation of the normal at theta equals to pi by 3 to the hyperbola 3x square minus 4y square equals to 12. So the given equation of the hyperbola is 3x square minus 4y square equals to 12. So this is 3x square minus 4y square by 12 is equals to 1. So 3x square by 12, that means x square by 4 minus y square by 3 equals to 1. A square equals to 4, b square equals to 3. Now he asks us to find the equation of the normal at theta, that means at parametric point. So equation of the normal at p theta is ax by secant theta plus by by tan theta is equals to a square plus b square. So this is a is 2, so 2x by secant theta is pi by 3 plus b is root 3 y by tan pi by 3 is equals to 4 plus 3 a square plus b square. So 2x by secant pi by 3 is 60, cos 60 is 1 by 2, cos 60 is 1 by 2, secant 60 is 2 plus root 3 y by tan 60 is root 3. equals to 7. So this 2 gets cancelled. Therefore, x plus y is equals to 7. This is the equation of the normal at the parametric point. If theta is the angle between the asymptotes is 30 degrees, then find the eccentricity is the given. So if theta is the angle between the asymptotes, then theta is equals to 30 degrees is given. Then we know that theta is equals to 2 secant inverse E. 30 degrees given. 2 secant inverse E. 30 degrees by 2 is 15 degrees is equals to secant inverse E. So this is equals to secant 15 degrees is equals to E. So we need to find out this value E. So 1 by E is equals to 1 by secant 15 degrees. So E is equals to 16 secant 15. So 1 by E is equals to 1 by secant 15 degrees. So this is equals to cos 15 degrees. So cos 15 degrees is equals to cos 45 degrees minus 30 degrees we can write. So cos A minus B is cos A cos B plus sin A sin B. So cos 45 degrees cos 30 degrees plus sin 45 degrees sin 30 degrees. So cos 45 is 1 by root 2, cos 30 is root 3 by 2 plus sin 45 is 1 by root 2, sin 30 is 1 by 2. So the LCM is 2 root 2, so root 3 plus 1. So this is equal to 1 by E is equal to root 3 plus 1 by 2 root 2. From this E is equals to 2 root 2 by root 3 plus 1. Let us rationalize. Root 3 minus 1 by root 3 minus 1. So 2 root 2 into root 3 minus 1 by A plus B into A minus B. A square minus B square. Root 3 square is 3 minus 1. So 3 minus 1 is 2. So root 2 into root 3 is root 6 minus root 2 into 1 is root 2. Therefore, E is equals to root 6 minus root 2.